Okay. Do you have it open?
Mm-hmm. I remember reading this part. I just don't know if I wrote it down. The first one.
I actually took a picture of that part on the slide.
Did you?
Yeah.
What does it say?
The samples are from simple random sampling. So a simple random sample is drawn from each population. X bar is normally distributed for each group.
And that's it?
Yeah, I think so.
I think so too. The X bar is the only one I was sure about.
Yeah. I mean, it says the words are the samples are from simple random sampling. It's the same thing from something as a simple random sample is drawn from each population, right?
Yeah. That's
The next one's T-score.
yeah. I'm pretty sure, but now I'm doubting myself. The thing that it makes me wonder because that's not something that's necessarily specific to this lesson. And so I'm like, wait.
They didn't really cover that specifically.
Yeah.
I think it's T-score. It's either T or Z. I'm pretty sure it's T.
Okay. Two samples are independent if
knowing which subjects will be in group 1 tells you nothing about which subjects will be in group 2.
Yeah. Okay, here it is. Here's
yeah,
the
now
data.
we actually have to do stuff. Okay, so degrees of freedom.
Wouldn't it just be 19?
Where'd you get that from?
N minus 1.
What's N though?
The number of samples.
Yeah, but how do you know that? You just looked at the thing.
Yeah, I just looked at Excel. So they're 20 units. So I just said 19 was the degrees of freedom.
Okay. There's a formula thing that will like give you all of those answers. Like it'll just tell you like degrees of freedom. It'll tell you the like p-value, like everything.
Where did you find that?
So if you go to File and then go to Options.
Oh crap! I just exited out of it. Hold on. Okay, File.
You go to Options.
Uh-huh.
And then on the sidebar, you click Add-ins. And the very first one that can do is an analysis tool pack.
Uh-huh.
Just click that and press OK. I'm doing it with you. And then it should show up if you go to data at the top, all the way to the right, it should say data analysis. It should have a new add-in.
And then it comes up with.
Did you download or install?
It didn't give me the option to install anything. Just a little data analysis box.
Data analysis now on your toolbar?
Yeah.
Okay. So if you just hit that, then it, then you have to choose which one.
Yeah.
So
it's t-test paired to sample for means, or
I think it's the paired to sample for means. Let me check it again. Oh no, I think it's the assuming unequal variances. Because it's saying perform a hypothesis test to determine if the mean bill at the Idaho Falls office is less than the mean bill at the Rexburg office. So it's assuming that they're unequal. Does that make sense?
Yeah. So, okay.
And then you have to put in the two variables. So just highlight all of the numbers in the first one and then all the ones in the second one.
Okay.
And then alpha is the level of significance. And that's 0.10. And then hit OK. So this says that the degrees of freedom is 38.
Well, then in the last lesson, it said degrees of freedom equals n minus 1. So why did it change? I guess that's only for matched pairs.
Yeah, maybe.
Because
yeah, that's how it is. In my notes, it's just matched pairs. That's definitely an independent sample, right?
Yeah.
Okay. Then I'm pretty sure that's right.
Okay, so then the question was degrees of freedom, 38. And then does it give us the standard deviation?
I thought it did.
Is the test statistic the same thing as a t-score?
I believe so. Yeah, I'm not sure how we're supposed to get the standard deviation.
Hold on, let me see. In
We need to use
in
the
the reading.
applet.
Sorry, what?
Do we need to use the applet for that?
I don't think so. In the reading, it says to use the Excel. To use Excel. It says using Excel, compute the following: mean, standard deviation, sample size. Let me see. I think I just did it wrong, but the number I got was 205.587, but that is gigantic.
How did you get that?
I just went to the functions in Excel, the little FX next to where you put the formulas, and then you can choose standard deviation and you choose your data.
So my data disappeared because, oh, do I have to go to sheet one?
Uh-huh.
Well, that should be right?
I think so. The only thing is that they have lots of different standard deviations that you can choose. So I chose standard deviation based on the sample, but there's also a population and then a different one.
I say just go with the 205. You got 205, 587?
Mm-hmm.
Okay. I say go with that.
Is that what you got? Or did you do it?
Well, just when I did the same thing you did, so.
Oh, okay. And then which one?
That one's just given, it's a t-stat. So negative 0.434.
Oh, sorry. Yeah, I was on p-value, but there are two p's. One tail and two tails.
So the p-value is the two-tail.
Okay. 0.666.
Wait, I think it rounds up to 0.667.
Are you sure? Because it's
Yeah, because the
6664.
makes the 4 a 5, and then the 5 will make the 6 a 7. Right?
I'm pretty sure you just go with the one that's next to it. So if just a 4 is next to it, so it would be 666.
Okay.
Right, Jared?
Yes.
I wasn't listening. When you're rounding, if it's like 0.66647 and you're rounding to the third decimal, it's just 0.666, right?
Rounding 0.66647. Put it back. Point. Write it down. Put it down. Okay. 0.666.
It's right there.
And you can do this. One, what's this do? So what? Where? Oh, third decimal.
Third.
Yeah.
Oh, cool. I didn't know you could do that.
Okay, I'm starting to second guess myself on on the unequal variances part.
Really?
Now the next, okay, so question 10, pretty sure that's fail to reject.
Right.
And then 11, it gives you the alternative hypothesis, which is they're unequal.
Mm-hmm.
So now I'm starting to wonder if the first one is supposed to be equal. Because it gives you two alternative hypotheses, and one is equal and one is not. Oh wait, no, the first one's supposed to be null.
What first one?
So if you go back to the original question, it gives you the null hypothesis and the alternative hypothesis.
Mm-hmm.
The first one has HA, which is alternative. So I thought that was.
Oh, yeah.
But it states that it's the null hypothesis. I think it was just a typo. But I don't know. Do you think we're supposed to go with the null or the alternative when determining whether or not it's equal or unequal?
When determining whether or not it's equal or unequal.
Like, you know how when we selected the thing saying two sample assuming unequal variances?
Oh, I see.
Like where we had to.
Yeah, I thought they should be unequal variances. In my mind, now I don't know if it makes any sense, but in my mind, I thought that was the right choice because this lesson is dealing with independent units, independent variables. But now that I say it out loud, I don't know if that makes sense logically.
Yeah, no, that makes sense. I'm just second guessing myself because now we're dealing with a hypothesis that is unequal, so I'm wondering, like, I don't know.
No, I think you're right. If we get all of those questions wrong, then we can do it again.
Yeah. We know what we want to do. So,
instead that you had used the alternative.
but see, that's implying that we have to select a different option because it says suppose instead you had used this hypothesis, which is unequal. I don't know if I'm making any sense. Like,
No, I know what you mean.
like, what are we supposed to do differently?
I'm gonna go really quick and see if I'm gonna do the other one with equal variances.
Okay.
Okay. Everything is the same.
It's the same.
Yeah. Wait, go to the questions and I'll read you the answer. We'll see if it's the same.
Okay.
Okay, go for it.
Wait, I thought you were reading them.
Oh, sorry. I just don't remember. It was the. Let me think. The two-tailed p-score is 0.666. T-statistic is negative 0.434. What else? Was there something else?
Degrees of freedom. Is it 38?
Uh-huh. And obviously standard deviation is going to be the same because I did it independently using that data.
Yeah.
So I guess if they're the same, no matter which one we use, then it doesn't really matter.
So, if insufficient evidence. Not sure which one. I think it's insufficient evidence that they're different.
Why?
Because, so if you scroll up to the question, it says,
Mm-hmm.
form a hypothesis test to determine if the mean bill at the Idaho Falls office is less than the mean bill at the Rexburg office, implying that they're different. So if we reject the hypothesis, then we're rejecting the fact that they're different. So we have insufficient, wait, no, we failed to reject, just kidding.
Mm-hmm.
So it would be the same. What do you think?
So if we fail to reject, it means that they are the same. We think they're the same, right? Or close enough.
I think so.
And so this is saying if we instead use the alternative hypothesis, then I think your first one is right. We have insufficient evidence that the mean dentist bills are different because we're saying that they're the same. Because this hypothesis is saying the hypothesis is that they're different. And so to reject the alternative would say that we can't say that they're different.
But we're failing to reject.
Right, but in question 11, it's actually use the alternative. So it's like, and for a second, that alternative hypothesis, you know.
Gotcha.
That's what I think. But if we get it wrong, then we'll choose the other one.
Okay, so you say insufficient evidence that they are different.
Yeah. Hold on, my computer's dying.
Carlos, the answer is ready.
Okay, did you look at 12 already?
I'm starting to. Unequal. You agree?
Mm-hmm. Sorry, I didn't say anything.
It's okay.
And then, sorry, for test statistics, did you get 0.845?
Oh, I didn't even get there yet. I'm still trying to figure out. Are we just staying with the unequal variances?
Yeah, I think so. I mean, I did the other one and the data wasn't any different, so I don't.
Yeah, that's true. Okay, let me plug it in.
Well, we could try both of them every time if you want, see if the data is different on this one.
Okay. Or we could just do one and see if we're right, and then you
Okay,
get if we're wrong.
we'll just.
It's the significance is 0.05, right?
The significant. Oh, yeah, yeah.
Okay.
So we fail to reject again.
Okay, wait. So degrees of freedom, or no, the test statistic. That's what we're looking at. 0.845.
Mm-hmm.
Okay. What's the p-value?
0.410. So we failed to reject.
Yes.
This one's going a lot smoother than Tuesday.
Yeah, it is. Maybe I should figure out the software.
Well, you did. Thank you.
Oh, now we gotta do confidence intervals.
It's the lower bound and the upper bound I always get wrong. Those are the last two questions.
Did you already get 16?
For which one?
The margin of error.
Yeah.
Sorry, guys. I'm just getting home from work.
It's okay.
It's okay.
We got ahead of the game.
We started without you.
I'm sorry.
No, it's okay. Don't worry. You can be grateful.
I am. I love you both so much.
So for the margin of error, does it matter? I mean, I had a formula written down from lesson 11, but I don't know if I can still use that for this one.
I think it's different for the confidence intervals. What did you get?
I haven't gotten it yet.
Oh.
Hold on.
What question are you guys on?
16.
Oh my god. You guys are like almost done. Holy crap.
You're welcome.
Oh! I thought you were going to say like 4 or something. Oh my god.
Yeah, no.
I don't know.
Well, we started before it was even 9, so we weren't waiting for you or anything. At all.
Like,
Yeah, I was just chilling here and we got on at like 9 or 8:40.
oh wow.
Let's just start.
Yeah.
Did you guys
It was
get
my idea to abandon you, sorry.
No, it's fine. Did you get to go back on like the last chapter and try to review all that stuff? Or no?
No,
I know.
not really. Well, I figured out this lesson, and I think this lesson is a lot like the last one.
Uh-huh.
So I think I know
Okay.
kind of what we did wrong.
Okay, so on number 16, I think I'm not getting the right margin of error because the formula I have doesn't even account for the confidence interval, so that doesn't work.
Okay. So I don't understand. There's a bunch of different formulas that you use. There's one for standard deviation known, and then unknown, and then matched pairs, and then independent samples. So how do we know which one this is?
Because it's lesson 13 and we're learning about independent samples.
I know, but in this lesson,
Literally the only.
Yeah, that's the only thing that you have.
What were you gonna say, Jordan? But in this lesson, what?
it covered, like on the slides, it covered all of the different formulas, like for confidence intervals.
Yeah. You're
Let's
right.
just go with that, independent.
So what's the formula that you have for that one?
It's kind of complicated. It's
Really?
the t with the little star thing, the square times the square root of first standard deviation to the second power over n1 plus s standard deviation 2 to the second power over n2. Yeah, it's kind of complicated.
Yeah, it is. But it doesn't have that in. Wait, let me
So
check
thought
before I
that
say
was
something.
supposed to be with the software. But we figured it out with the software.
The frustrating thing is that it doesn't have all of the information in the reading. That makes sense.
So I did this and I understood it, and now I don't.
So you did the formula that you just gave to us?
Did I what?
Have you used this formula before?
No, I don't know how to use it. I'm pretty sure. I'm pretty sure you use the software somehow, but I don't remember how. I'm gonna pull up the video again. You guys hear that?
Mm-mm.
Okay, so we basically do the same thing. We just do the equal variances not assumed or whatever.
In Excel?
Yeah. So, oh wait, we don't even have a file for this. How do we not have a file? Yeah, I don't understand how we're supposed to do this with no data.
I think it's still using the data from the one above question 12, the freshman dinner.
It's still on that one.
Yeah, because it says for the next 6 questions.
Yeah.
Okay. So, what's the freshman dinner?
Tiene chupón.
Posible.
Ouch. And do you already know what you're doing, Jordan?
Kind of. It's supposed to, so you're supposed to find the lower bound and the upper bound.
Oh no, I meant for 16.
Yeah, that's what I'm talking about.
Okay, wait. Find the lower bound and upper bound for.
Is there a formula for that?
No, I'm just making a histogram in Excel. That didn't work. Now I feel stupid.
Yeah, I'm kind of confused.
Hey, were we supposed to use the t-test paired 2 samples for means?
What do you mean?
In Excel? Well, actually,
For this question?
no, I meant in general. Because for that, when they're paired, you have to have the same number of data points, and we don't.
I don't know.
And because they, they got to be paired. Mind.
Yeah, I don't know.
Don't you have to use the applet for those questions?
I'm not sure.
I'm pretty sure that's what it said on one of the videos. Like, that's how you get your upper and lower, that you're looking for questions. What is it? No, for 17 and 18. Are you working on 16 right now?
I'm on 16.
Yeah. I just can't
I'm just
find
trying
any
formula. Do you know what the critical value is? Or how to find that?
It is 2.109816.
Okay, wait, how did you get that? Oh, the
So,
T critical two tail.
uh-huh.
Okay, I'm just gonna plug these numbers in. Hoping I get them right. So what would the first standard deviation be?
Deviation.
Yeah.
First one. You get it ready?
No.
Just doing it the same way we did last time. Which, I'm just guessing.
Okay, so insert function. Okay, wait, so there's standard deviation P, standard deviation S, standard deviation A.
Standard deviation S, because that just means from the samples, not the population.
Okay. Wait, how would we have 2 standard deviations?
I guess if you did a standard deviation for each sample, like,
The standard deviation is supposed to be for both samples to begin with, right? Like there's one
Right.
standard deviation between the two.
and the formula asks for 2.
Yeah. Okay, yeah, no, it says, no, you're right. The first sample standard deviation, and the second sample standard deviation. I'm just gonna do it that way.
Okay.
Okay, it didn't even give me a number.
Okay, well, I got both the numbers.
What are they?
The first one is 3.420,
Okay.
and the second one's 4.517.
Okay.
Or if you want, I can give you the full numbers. I just realized maybe I shouldn't have rounded.
I think it'd be fine if you know.
First sample size is 13. One is 11. Alright, I hope I'm doing this right.
We'll see. Do you get anything yet?
Yeah, I'm getting there. This is a long, complicated formula. Do you have the formula, either of you?
No. I don't even know where you got it.
I just got it from the tutorial slide.
Which one?
The part 2.
It was on the video?
Yeah. It was at the end of the second one.
Okay.
Okay, wait. So the critical value is 2 point. Okay, so I got a number.
Great.
I'm hoping it's right.
What's the number?
I think it is 5.813.
We'll see.
Wait, but this doesn't. We didn't incorporate the 95% anywhere. So how could that be right?
But where would you add that?
I have no idea.
It doesn't say that in the formula, does it? No, it doesn't.
No.
I can't even find the formula in the video.
I'm looking it up right now. I was
Hello, this is Brother Kumar from the Math Department. This is a continuation of the videos of the inference for achieving independent samples. So now what
Do we know the standard deviation? Like from the, no, we don't. Um,
I still can't find that formula. It's towards the end of the video.
yeah.
Wait, look at the information again. It says determine a 95% confidence interval for mean 1 minus mean 2. An estimate for the difference between. But it says determine a 95% confidence interval.
So the critical value in parentheses, it says use levels of confidence and degrees of freedom. So that's where we'd incorporate it, but it kind of already gave us the critical value. So I'm not sure how they got that without us putting in the 95% confidence thing. Does that make sense?
Mm-hmm. Well, the difference between the means is 1.467.
Do you think this is still the two sample assuming unequal variances?
I think so.
Because nowhere does it ask to put in the level of confidence.
I think you should just try it.
What?
You should just try what you got. Like you said, they didn't ask you to ask. Isn't it the 0.95?
Okay, so if this is an independent sample, then the formula I just used is correct. But the formula for standard deviation known gives like you can put in the level of confidence in the formula to figure out the margin of error. So I feel like we should be using that. But the standard deviation isn't given. I don't know. I think we should just use that one. Because
Which
in
one?
the formula you can put in the level of confidence. Just 95%.
Mhm.
So the formula is z times standard deviation over the square root of n. You guys have that?
Yeah. I also have t star times s divided by square root of n.
Yeah, so that's for the standard deviation unknown. And then there's two more
Okay.
formulas for matched pairs and independent samples.
Okay.
I say we just go with the standard deviation known. That'd be 1.96 times, what's the standard deviation? You use the standard deviation S, right?
Mhm.
Is it 3.928?
The standard deviation.
Yeah.
Hold on, I didn't do it for both. Yeah, 3.928.
And then the sample size. Is that just both of the samples added together?
That's what I would guess.
13 plus 11?
12 plus 10.
Wait, what? Oh, yeah, you're right.
Because, yeah.
Okay, so I got 0.349, which runs out to 3.350.
0.350.
0.350.
Okay.
If I get these wrong, I'm gonna be mad. I won't even know what these are.
Okay. Upper bound and lower bounds.
All right, I have no clue with that. In the video, he just has it. Like, it's just in his file. Like, he doesn't even say how you get it. Like, it's just there.
Okay, I'm pretty sure we did 16 wrong.
Really?
Yeah, because we have to find the confidence interval first, and then it says determine the margin of error for this 95% confidence interval. So I was just looking at the reading, and it says how to find the confidence interval. And then it has Excel instructions.
Well, there's a table for it that tells you what the number is for each percent.
Let me see really quick. Huh, look at this.
Right after that results, my secretary is this stuff right here. That's say that you're 99% confident. It's this stuff right here. So I got some point said that's what the difference between these two numbers with the one here. The last picture was a little is there a difference? Can we tell if there's a difference between 2 and 95% confidence?
I'm so confused.
Okay, I think I just found the answer. Let me see.
How'd you do it?
Still not the. Is the standard error of the mean the same thing as the margin of error?
Probably.
Okay, so go to the reading. And tell me when you guys are there.
And there.
Okay, then go to under section 4, confidence interval. Go to step 4. And then open that Excel file, the quantitative
Okay.
inferential procedures. Did you open it?
Which one? It gives me a
Like,
unit 1 file. A unit
Do the procedures one.
oh, okay.
And then it has the 2 sample t-test sheet. And it has the margin of error there.
Oh, okay.
There we go.
And then it has all those numbers. So we just have to move the data over to that sheet.
Wait, what kind of test is it?
I did the 2 sample t-test.
Okay.
It's not paired.
Hold on, so are you plugging in the numbers we have?
Yeah, you're just transferring the data, right?
Sorry, what? What'd you say?
I'm just confused as to what we're supposed to do.
You're transferring our data to that file, right?
Just the variable parts?
Uh-huh. That's what I did. So, um, so now I'm gonna check and see if our numbers are the same. 3, 4, 5. Yeah, our T was right. And p-value was right. Oh, except the p-value would be 0.411.
For question 14?
Yeah.
Okay.
But this is the tricky part because even with the standard error of the mean, it does it separately for each variable.
Yeah.
But we got the other numbers right. So is the upper and lower bound just, and I guess I don't understand exactly what that's saying.
Yeah, I don't know how you're supposed to get the lower and upper. Oh, is it just the plus minus formula that they give us
Which one?
for independent samples? So you guys didn't have any of that, but there's a formula for the independent samples, and it's a plus or minus formula, which kind of makes me feel like it'll give us what we're looking for. I don't know, actually.
Try it.
But you can't plug in the confidence interval anywhere. Yeah, I'm confused.
Well, I don't know. Hey, in that Excel sheet, Jordan,
Yeah.
if you click on the number it has for confidence interval, you know, the section at the top with the formula, the confidence interval formulas are super complicated and long. So
Okay,
maybe
wait. Which Excel file?
the two simple t-test for means. The one that has the standard error of the mean that we were looking at.
Where did you go?
Just click on the number for confidence interval, like 5.147. And
Yeah.
that formula at the top, you can see it pop up. It's
Yeah.
super long and complicated. Is that the one that you were doing?
No.
Oh, I was thinking maybe you were finding the confidence interval.
No, I think that the formula I was doing was to find the margin of error.
But are those the confidence intervals right there? Are those the upper and lower bounds? Because if you switch between them, the only difference is the plus or minus sign. Do you see that?
Yeah.
So I'm thinking maybe those are upper and lower bounds.
What's that noise? Sounds so weird.
Jordan's riding a motorcycle.
I'm doing what?
Carla said, "What's that noise?" And I said, "You're riding a motorcycle."
Okay, wait, I'm gonna go back to the video real quick. Yeah, that's right. That's what that is.
Yes.
The lower and upper bound are the confidence intervals.
Ha ha.
I don't know how I didn't catch that before. It's so confusing. They don't like tell you anything.
The problem is that it's not well organized. It's like all the information is a salad bowl, and so we're asked questions from things that we learned 3 weeks ago, and then we're given questions from things that we haven't really learned yet, or you know.
And they don't explain things the whole way. Like you're just supposed to assume. I don't know. You're just supposed to know that the confidence interval is the same as the lower and the upper bound.
Yeah, and like in the videos, they don't tell us where to find that graph in Excel, but then it'll have it somewhere, but no one tells us how to get there, you know. So all the information's there. It's just like really hard to find.
Okay, so what did you get for 16?
I didn't get anything yet. I was thinking maybe just because it has one mean minus the other mean, maybe we subtract those two standard errors of the mean, but this is all guesswork.
I'm gonna go through the video again.
Is, I should say, not confidence interval. It says is a confidence interval, it's not a confidence interval. I'll just do it right here. It's either match pairs or samples. Is first of all, it's a confidence interval. So going down here, what we do is instead of the mean,
They actually don't even cover it.
these two numbers are the number of units down here.
I feel like this gets so much during the videos.
Yeah.
Calculate this as a score itself. Okay, so let's go back to the first example that we covered in the hypothesis test. How do we look at this in terms of confidence intervals? So if you remember, there were two groups.
Did he say something about it?
It just gives you the formula. He doesn't cover, like he doesn't give an example.
Well, then, do you want to just try the 0.350 that you found and see if that's it?
Yeah. I'm pretty sure that's it. Just not positive.
Okay.
Okay, so what were the lower and upper bounds?
The lower bound is negative 2.214. And the upper bound is 5.147.
Carla, we gotta catch you up.
Yeah. I'm so sorry. Like, I tried to catch up in like certain parts, but yeah, I got a couple things. But like other times, I was like, oh my god, they're so far ahead. I can't.
You're
Don't
good.
even worry about it. Number 1 is true. Number 2 is true.
No, really.
Do you want to submit it, Jordan?
Yeah.
So that way I'll just give her the ones that are right if we get any wrong.
Okay. So you got 68.42%.
Okay.
Um, so 6 is wrong. 7 is
Which-
wrong.
6 and 7.
9 is wrong. 13 is wrong. 16 is wrong. 17 and 18 are wrong.
Are you serious?
Yep.
Oh my god. I feel like up till this week, everything was fine, and like these 2 lessons just messed everything up.
Yeah.
And we have a test.
17 and 18, I don't even know what to do about that because
Yeah,
it literally gave us the number.
I don't know what to do about any of these.
Yeah, these are all the numbers that they gave us. I don't even know how to even try to pretend to fix it because it was from Excel.
I'm gonna try and change the data analysis to something else, see if it's different.
Hey, but we got 11 right. What I don't understand is how we can get, like, for 13 and 14, how did we get 13 wrong but 14 right?
Yeah.
Because it was from the same program in Excel. It just gave us all the numbers, so how did we get one wrong?
Maybe we used a different data analysis and one of the numbers is right and the rest of them are okay, wait.
Do you want me to just give you the rest of the answers so I can catch you up? Okay. Number 3 is a simple random sample, and X bar is normally distributed. Number 4 is t-score. Number 5 is knowing which subjects will be in group 1 tells you nothing. Number 8 is negative 0.434. 10 is fail to reject. 11 is we have insufficient evidence that they're different. 12 is not equal. 14 is 0.411. 15 is failed to reject.
Alright, good.
You got them all?
Yeah.
Okay, good. The other thing that's kind of frustrating about this is that I feel like when we figure out the answer, we'll get all 7 questions right.
Yeah. So I think I know what we did wrong for question.
Really?
Well, one of them. Question 7.
Uh-huh.
It's the question is, what is the sample standard deviation for Rexburg? And we did the standard deviation for the entire thing, not just Rexburg.
Yeah, you're right. Okay, so what's the right answer?
Hold on. Should be 206.637.
206 point what?
637.
Okay.
Not really sure how to fix the rest of it.
I have no idea. Oh. Okay, I found the answer, number 6.
What is it?
37.996.
Is it because Excel rounded?
Yeah.
Are you serious?
Uh-huh.
How did you figure out the actual number?
I opened the data again and then moved it over to that quantitative procedures Excel sheet, and it gives you the degrees of freedom in there. That's what it says. 37.996.
Okay, let's just use that from now on. All right. I have to re-put in all these answers. I got 3 right.
Oh, and then you were right. The p-value is 0.667, but it's because for number 9. But it's because I think Excel rounded again, because in that sheet it does it differently.
It was 4 right with the t-square.
Uh-huh. Wait, what? What'd you say?
Number
What?
4 was right.
Yeah.
Yep. Okay, so sorry. Tell me the degrees of freedom again for number 6.
37.996.
And then the standard deviation. I don't even remember the number. 206 point something.
0.637.
It's 206.
206.637. Mm-hmm.
And then the test statistic is negative 0.434.
Yep.
The value is 0.67. And did we get 10 right?
Yeah,
So it's failed.
it's failed to reject.
Wait, what was 9?
9 was 0.667. And then was 11 right or wrong?
That's right.
Insufficient evidence that they're different.
Mm-hmm. Twelve is not equal.
13. No, we got that one wrong.
Right.
Are you plugging in the data?
Uh-huh. Okay, so for the freshman data thing, what was the first question?
First question.
The test statistic. That is 0.845. I don't know. Don't know what else to do for that. That's what it says. Unless I don't know what the test statistic is. Oh wait, maybe that's where. $16.516. Maybe that's where we're supposed to put it into the applet.
For what?
That's
The
what I
test statistic. So we put 0.845 into the t-score for the applet, and then put the degrees of freedom in.
Oh.
like your loads.
And then I got 0.410.
For the test statistic.
Yeah.
And do you have the p-value?
We got the p-value right. It was 0.411.
15 right?
Yes.
Fail to reject.
Uh-huh.
Did we get 16, 17, and 18 wrong?
Yep. Still don't know how to do 16 though.
Yeah, I think
Yeah,
I
I think
figured it out though.
Really?
I think.
Um,
Hold on.
hold on.
So I think I'm supposed
I think
to
I'm
use
supposed
the formula for the
formula for the
independent samples.
samples.
Well, we have to use the applet.
We'll just use the applet for that.
So do we have the levels of
So do we have the
confidence?
levels of confidence?
We have the confidence interval.
I think we're supposed to plug that into
We're
the
supposed to
applet.
plug that into the applet.
Oh, the level of.
Find one of
Just find one of the.
What?
Wait, the level. Is the confidence level the same thing as level of significance?
I don't know.
I don't know.
No, I don't think it is.
No, I don't think it is.
Okay, then we have the confidence interval, but not confidence level.
Okay. All right. I think.
Okay. All right. I think.
So it's 95%.
So it's 95%.
Yeah.
Mhm.
Cool.
Yeah.
1.96.
1.96.
So I think we plug that into.
So I think we plug that into the.
And then put in the.
We'll put in the.
If we have that.
We have that.
Okay.
And then I think the area
And I think the area
is one of the variables for
is one of the variables for
the formula.
the formula.
Hold on. So we do have
So
the.
we do have the.
What'd you say?
We do have the
We
degree.
do have the degrees.
Yeah.
What is it?
What is it?
It's 16.562. You're working on 16, right?
Yes.
Yes.
Okay.
And so I think I have an answer for
For which one?
I think it's 2.2.4.
2 point what?
654.
654.
And I seriously don't know what to do about 17 and 18 because it literally just gives it to us. What they give us is wrong.
Well, I don't know. There's not a lot that we can do.
All right, Carla, we give up. Give us the answers. I have no idea. It even says it in the video.
Yeah.
Yeah.
Are you sure you have the numbers
Sure
right?
you have the numbers right?
Yeah, I just well, let me read it. It's negative 2.214 and 5.147. Is that what we have? Yeah.
I don't know, mine are gone.
I don't know when you're gone.
Yeah, it is. That's what we had. And then even in the reading, it says when it gives you instructions for finding confidence interval, it says to open the Excel sheet and the confidence intervals will be given in cells H23 and I23. And so it doesn't
Who do you
even tell
think
you how to find them.
do you think Excel is rounded?
Rounded. Wrong.
I don't know. This is the one with the crazy long formulas. have no idea.
None of the definite. They're helping. Not.
Unless we're just supposed to use the means somehow, which I don't get that either.
Hold on, I'm Googling it. Does it say how to find the lower bound and the upper bound in the reading?
No, it doesn't even have those words in the whole reading.
Yeah. Okay.
Let me check the. You guys. Get us the last.
Okay, so
No, it isn't on there.
Would you just check?
I checked the previous chapter to see if it said anything about the lower or upper, but I didn't find anything on there.
Well, I have an assignment for another class due at 11, so I think I'm gonna have to submit it and be good with getting 2 wrong. Hopefully it's just 2.
Hopefully.
Okay, so I'm gonna submit it right now. We got 4 wrong.
Ugh.
13 is wrong. 13, 16, 17, 18.
I thought we got 13 right the first time.
No, we got 14 right. We got 12 and 14, but 13 was wrong.
What did you put for 13?
0.410.
Well, I'm about to. What's the percent?
78.95.
I'm about to just submit it because I'm ready.
Yeah. I don't blame you. Okay. I did talk to Sister Wilkinson. She did answer.
Okay.
She said that we can meet once a week, but we still have to post a video in both collaborations.
Okay.
And so
It can be the same video.
yeah. We can post the same video on both.
That would work so much.
That's
But we
exciting.
would have to do it Monday or Tuesday because that's when the first one's due.
Okay.
So what day do you guys want to do it next week?
Um.
And if we're going to do both, we might want to meet a little earlier.
Yeah, we have
or
to.
on Monday.
Wait, what? Sorry, you guys were like.
Sorry. I was saying if we do both, then we'll probably want to meet on Monday or earlier on Tuesday so that we have time before we submit it.
Yeah. That would be a long. We keep having an hour.
Yeah.
But I'm should be as long as work goes back to But if you guys want to meet up, I think that we shouldn't.
Yeah.
Unless we do meet, then it'll. But since we'll be coming to instead of
Is it okay if I text you guys about a decision? And hang
Yeah.
up now?
Yeah.
No. Okay.
All right.
See you. Good meeting. See you guys later.
Thanks.
Bye.
Bye.